Do you know that MySQL is not horizontally scalable? Or can you use sharding in case of an RDBMS? Or should you use an ORM based tool to write your queries, or should you resort to writing plain queries? Welcome to Bottom Up. Today in this video, Brijesh Kushwaha, Ajit Kumar Singh and myself Kunal Singh will try to answer these questions around RDBMS. So please jump in, go watch the video and share your feedback in comments.
Since we are here discussing mostly about the optimization techniques, or I would say, yeah, what are the optimization problems and the techniques that we can use to, solve those problems. So, another side, like one of the solution that we were thinking is like we should be writing our queries in a way so that uh, the query plans. So whenever we write, queries or stored procedures, there is a plan which are generated by the optimizer, which basically says that where is your data present and how I should, go and retrieve that. So the first time when an ad hoc query or the stored procedure executes, this plan gets created, and this is basically stored in a memory area, which we generally call it plan cache or query cache, so that at later point of time when same or a similar query comes, it will basically use that cache or the query plan and quickly fetch the data. It's not going to create the query plan again. So what my point was that when we write ad hoc queries or let's say store procedures, this plan caching happens uh, more when we are using like ORM. In that case, basically this query caching or plan caching is not helpful, although there are ORMs which claims that they do help with this query caching. So my opinion was that ORMs are generally not helpful with this.
I can talk a bit with ORM and the plain queries. So one very basic difference is that when we are writing the ORM, so advantage we get is we are still using the object and our the same programming language. So we feel more comfortable in writing the query rather than writing in the SQL. That is the advantage. But at the same time, whatever ORM query we are writing, that needs to be converted into SQL query and then needs to be executed. So that is always an overhead. So that will slow down the things. And also, there are possibilities which you can write in the store procedures, but you will not be able to write it easily in the ORMs. So using the store procedures, if you want to gain performance, that will be more useful rather than the ORM. So whenever you hit performance bottlenecks, then probably moving away from the ORM could be a better choice.
You are saying we cannot write the stored procedure in the ORM language, is it? Or
Yes, that means when I say ORM, that means you are, for example, in entity framework, we use a Fluent API, right, to write the. So whatever query we are writing in ORM language itself. For example, in Java, we use in C# we have something called LINQ, language integrated query. Sorry, LINQ. Yeah, LINQ. So there, what happens? Whatever you are writing, you are not writing SQL. You are writing in C#, pure C#, and that will be converted into SQL query. And each time, whenever you execute that ORM query, that's going to convert it into SQL, send it to the database, and then from the database, you're going to receive the response. But if you have a stored procedure, then you just send the name to the DB of the stored procedure and the required parameters, right? you don't need to send the whole query.
Hmm.
So that is one advantage. Second thing is, if you have the stored procedures that is inside the database itself, so you don't need to convert that. In case of ORM, you are converting from C# to SQL queries.
Hmm.
And also, I think um, we will not have the full freedom which we get when we write the store procedures in the database itself.
But is it possible to write the stored procedure in database and just using the ORM when I want to trigger it, I can just trigger the call to it.
Yeah.
I think it should be
Okay.
possible because I've
No,
seen it in at least entity
Then
framework,
yeah, I have seen that
probably.
in Entity
okay.
framework that you can call stored procedures from your
Hmm.
EF query, EF code jo bhi hai.
Hmm.
But in
Acha,
that
Uh,
case,
hmm.
the logic which you are writing, right, that is not in your C#, that is in SQL.
yes,
Hmm.
yes.
Okay.
I think
Brijesh, you have.
another I would say disadvantage or the downside for using ORM is uh, you never know like how your ORM is going to prepare your queries. Let's say you have multiple entities that you are trying to query. Although there are ways you can specify that hey you need to use this join or that join, but in most of the cases your ORMs you know are not smart enough to write efficient queries that is like which join you have to use or whether you need to use a subquery or which could be more performant than joins in some of the cases. It's not like they're always slow. So
Hmm.
that I would say is uh, considered to be a downside at you know some cases because your ORMs are not that intelligent to decide or may end up writing inefficient queries.
Okay, so I agree to this point. I have few supporting points which I can discuss when maybe discussing the query optimizations. That okay, you would have written some queries. Now you can tweak the queries based on some of the suggestions I have read in this high scalability, uh, what is that highly scalable MySQL book, right? So but I am not sure. Basically, I'm not sure whether Hibernate is exactly converting it into a very highly optimized query.
Yeah.
So there is, I think, no way for me to know that. Um, so even I feel that I think I can talk about at least couple of points there. One thing I just want to bring here is okay. So one is okay in plain. What are the pros and cons of writing to ORM? But essentially, like okay. Does using ORM make your query slow, right? Would that be a question, right? Which I wanted to bring the focus to. So I think Brijesh, I think partly already answered. Yes, it might in some cases where it's not able to write the efficient queries. Okay.
I think the major advantage which we get by using the ORM is that maintainability of the code, that
Hmm.
you don't need to convert data from tabular structure to entity,
Hmm.
and this is provided out of the box by ORM. And
Correct.
you are able to write all the logics in C# or your main programming language, be it Java or C# and any other programming language which is providing the ORM. So that's the advantage we get. But until unless, I mean, there is also a saying that we should not do the premature optimization. So if we really don't need to go behind that level of optimization, I think it is better to use the ORM. But when the need arises that you need high performance, that is where we start seeking into these directions, like where to gain the performance.
Okay. So we are kind of agreeing. Yeah, Brijesh, your point.
I think there was one point which came to my mind about the benefits of using ORM. Obviously, we agreed upon using the heterogeneous storage that you could with a single ORM, you could persist your data on multiple storage systems. Like you will not be bothered about how does your ORM is doing. Like even you are not uh, you know understanding that completely, or our developer may not be understanding each and every storage mechanism completely, but with the help of ORM, they can use it. They can retrieve or persist the data. And another point that I think would be like when you are these probably will help you in design some event driven systems. What I meant to say is like based on what entities you are modifying, you have that luxury to define the various subscribers, which we can like you can kind of notify when your particular entity changes, which is I would say a benefit of using ORM than directly writing your updates to the databases. I am not I don't have a supporting point to validate this, but I feel like this can be easy to design or code.
Hmm. Hmm. Okay.
Yeah.
Okay, I think we are generally agreeing that yes, ORMs are good when you are, let's say, starting with an app and it helps you quickly write, quickly take the overhead of writing your own plain SQL queries, and also then writing the translation between the object model of your application and the relational model in the database when you are using a relational database. But when it comes to a point where you have to optimize it and really optimize it to the last millisecond, last microsecond, then there we might be better off writing our own plain queries because we will be able to optimize in a way we feel is the most optimized query, because our queries then needs to be tweaked according to how the query optimizer wants us to write the query.
Then, do you want to talk about indexes and the statistics?
Yeah. So I think, yeah. So Brijesh, one point is, let's say now when you are setting the context, now when you want to, okay, so how does it usually start in a company is people will see the P95 and P99 of your APIs, right? And by looking at your P95, P99, they will see the P95 is 5 seconds, 10 seconds, maybe 2-3 seconds, right? And which is not acceptable if at least if it is a user facing API, right? Now, then you will observe, okay, where is the bottleneck? So there are tools like New Relic, which is very helpful. You can use the New Relic, and then it will tell you that, okay, which layer the bottleneck is. The bottleneck is at the application layer. The bottleneck is uh, at some of the network calls that you might be doing, right? So there it could be the bottleneck, or the bottleneck is at your database layer, right? So let's say now let's take the case of where the bottleneck would be at a database layer. So essentially, in more than one cases, what I mean, multiple cases, what we observe is it could be because the indexes are missing, the queries are slow, and maybe the queries is not written in the proper way. Maybe there are too many joins in that query. Because of all these reasons, it could be slow. So what will be your thoughts in, I mean, taking this scenario, what approach a developer should take there, right? To basically optimize and make your DB layer faster in that all those cases.
Yeah. Definitely. So like index by definition says that it will help you retrieve data. uh, I mean it will help you jump to a particular location uh, and then fetch the data. I mean I mean like if it is not present, the uh, normal use case would be like you have to query row by row or basically pages by pages. Now with the help of indexes, it gives you luxury to jump to a particular uh, page or the rows and just read the data. So yeah, I mean, definitely, if indexes are not present, there are you will basically look at your query pattern. I mean, I am talking mainly about like how to decide which index would be helpful for you. So uh, yeah, there is a best practice that you should always maintain a primary index, because that actually helps you, to get your data sorted in the store. Uh, so when you decide a primary index, in some cases it is said as cluster index or primary key, which basically uh, in turn gives you this primary index. So this
Yeah.
primary index basically helps you your data to get sorted in the memory, so that when you query, it is actually easy for the query optimizer or uh, the program to decide where it should look into, like which data pages it should jump upon and look for the data. So yeah, always ensure that you do have that the primary index, and then as you look at your query pattern there, you could think about your secondary index, like which are your columns which are like queried frequently, or they could give you data even you are not interested in querying that column or attribute for which you are thinking of making index, but it can help you in retrieving other uh, columns or attributes. So yeah, it's a again thoughtful decision you need to take, like which columns you need to index upon. And yeah, like statistics basically is help you to keep your data up to date. Basically it will help your indexes to figure out uh, where should it look upon. I mean, just keeps your data up to date so that your query or index can better give you better result and not be confused about. Yeah,
Hmm.
that's the thought about the indexes.
Okay, so Brijesh, okay, you talked about the cluster index, right? So cluster
Mhm.
index are the primary indexes, which typically will most likely everybody creates, right?
Yeah,
But many times when we are writing the queries will not always be based on the primary index, right? So in those cases, then you will have to go about uh, adding additional indexes on the table.
yeah,
And then how would you suggest what could be the general approach, right? List out what are the non-cluster index, so as to say,
yeah,
and apply them, right?
right. Yeah, I mean, so non-clustered index is like kind of, yeah, I mean that's a fair point that when you are trying to filter your data which is not basically on the column that you have created an index upon, but when you query data based on the other columns, uh, we generally try to uh, like best use of that cluster index column, so that even like I would say you are somewhat sure that this could be a range of data where you know where this like where my result could be falling upon. I'm basically referring to the cluster index column. That I mean, if your design is such that you could not directly can query that cluster index, but like you can query a given range for that. Just I would say try to use that range. Basically, just take a I would not say guess, because again you don't want the guess data. You want your actual data. But again, if that is possible, definitely try to use it in all your queries. But there are all other type of indexes which you can create. Again, those are going to take additional storage for storing their uh, index structure.
Hmm.
But yeah, I mean you can create it. There are concepts of covered indexes, basically covered index is nothing but whatever query you are making, it the indexes are helping those to retrieve. But so I am saying that if you are, let's say, what you can do is like there is a cluster index, obviously it is created on a particular column. What you can do, you can include other columns which you think that they are also queried frequently. Let's say id is your index clustered column, but you are kind of interested in getting names frequently, or uh, kind of any other attribute. You can like include those while creating the index. Those data can also be put at the like leaves, I would say. So index is a b tree. Basically when you traverse the index, it will definitely based upon the key for each you have decided when you are creating the index. But as you move towards the labels or the leaf labels, the data those are present. Like you can also include other columns data to that place, and so that those are actually faster. I am actually not sure if it is true for MySQL, because that's basically a concept for MS SQL Server, where you can, while creating the index, you could include some more columns for which data is also part of index structure, and not that you have to jump to a page for querying. It is actually available
Okay.
on the index structure.
So you are
Yeah,
saying these particular columns are available on the primary index only.
yeah.
Okay. So personally, I have not heard or used anything in MySQL as such.
I think Ajit probably knows about the include keyword which use we use, right, Ajit?
No,
No.
no. I mean, with the clustered index you are talking, right? Or non-clustered?
Yeah, any of it. Basically, your index structure is separate than the actual data, right? When you are creating index. So what I am proposing is like, so when
Okay,
you are
just a
creating an
naive
index,
question here. So when you're
yeah.
creating the clustered index,
Mhm.
so in that case, do you still get a separate structure for the index, or the order itself is the structure for the clustered index, which is
Yeah.
created on
So
the primary key?
yeah. No. So in case of cluster index, there is no separate data structure gets created. It's just that the table will be ordered in the fashion of the cluster index. So
Okay.
usually, primary key is the cluster index in
Okay.
the table. And so let's say the primary key, very simplistic case, is an auto increment ID, right? Now your table itself will be ordered based on your primary key, which is in the incremental, sorted based on the primary key in the ascending order. So
Okay.
that's your cluster, right? So that's the reason we call it cluster index. So in case of just contrasting it with a non-cluster index, in
Mm-hmm.
case of non-cluster index, you will get a very special separate data structure, right? Which
Yeah.
will, and then with those, the pointers will point to the real data sets where the data sets are stored.
Correct.
So nothing like that happens in case of cluster index.
Yeah. So when we are creating an index, and if we include the column, extra column, right? So for example, let's say you have the employee and you have date of joining also, and then you have name as well. So let's say you are most of the time you are going to query based on the date of joining. So it makes sense to create a secondary index, or a non-cluster index on the date of joining, right?
No, yeah, correct.
But at the same time, I need name also when I'm
Yeah.
making the query,
Mm,
like date, name of the employees who joined by this date.
mm.
So Brijesh, you are suggesting that when I'm going to create the secondary index or the non-cluster index, there I'll include the name also in the index with along with the date.
So yeah, so there are two things. One is when you are creating, at that time you are selecting multiple columns or not. Like you are creating index on one column,
Hmm.
and another case is you are creating index on multiple columns, just as like your uh, syntax says that
Composite primary.
create
Okay.
Composite
index on
index, or
column.
yeah,
Yeah,
just
composite
simple
index
index.
basically.
Yeah. Mm,
Yeah.
mm.
And so what my point is that you create index on one column, but
Okay.
when you like get to the end of the index hierarchy and gets to the last level, there particularly you can have additional columns too. So it is actually feature provided by SQL Server. Again, I would say that
Okay. Hmm.
yeah, you can.
Okay.
So syntax goes like create index on column 1, right? Create index name on column 1, and then you said include column 2 and column 3. So
Okay.
that actually says that your index levels will be again contain the column 1 only as a key. So,
Mm-hmm.
and you will can traverse based on it. But when you come to the leaf level, you will get again the column 3 and column 2. So this index will help you in query like select column 2, column 3, where column 2 is where column 1 equal to this. So what is happening that in where clause you are filtering only on the column where you have created index, but you actually getting your select values also as a part
From
of your
the
index
lookup
structure.
itself.
Yeah,
From the
from
lookup
your
is
index lookup itself, you're not
okay.
basically jumping to the
Okay.
database.
So we are not modifying the. We are not including extra column while creating the index.
Yeah, yeah,
Uh, so index is created on the one column only,
yeah,
but
yeah.
in the MS SQL server, we have option that you can choose to include more columns, so the data will be available on the leaf nodes, so it
Yes.
won't go and fetch again. Yeah. Okay. Now I have another question on this one. I mean, this is also like debatable.
Hmm.
One is like using GUID or auto incremental integer ID for a primary key, or sometimes using the primary key from the meaningful data which is already available in the entities. For example, let's say in India you are creating some financial records, right? So PAN card you can use, right, as a primary key, but at the same time I get arguments that okay, don't use that, but use a GUID or integer, and then also GUID or integer. That is one question. And second question is, when we are going to use the existing data as the primary keys, right? So many times what happens, instead of one column being unique, you need to combine two columns, and then you need to use the composite primary key. So what is your opinion on these 2 points?
You mean to say like advantages of using like a single auto increment versus a composite
GUID, GUID.
GUID?
First of all, GUID or integer, if you're using a separate data itself, a separate
Hmm.
column itself, rather than the data being from your the domain, right?
Right.
You are
Yeah.
creating a separate column itself.
Yeah.
So if let's say you decided that I'm going to do that, creating a separate primary key itself. So there you have option to create GUID, or you can use integer, or you can use some other mechanism to create a separate unique ID. So I mean,
Yeah.
one argument comes with the GUID is that it is big, so it takes
Sure.
more space to store. On the
Yep.
integer, you have less space to store. That is one point. But at the
Hmm.
same point, using integer, so if integer, same integer can be primary key in different table also, but that will not happen in case of GUID.
Mm. See, there are multiple ways I would say to design this system. Obviously, the debate about the storage is pretty transparent. That if you are going to use GUID, you are going to take more storage, and you are going to use integer, it will going to less storage. The pretty transparent difference is that you can at some point of time can exhaust your interlimit, right? Whereas GUID can gives you leverage of storing. You already know what is that. 32 bytes? No.
36, I think,
Yeah, whatever.
36
So like
bytes.
yeah, so in case of GUID, you have your limit is pretty huge. There could be many more years. I mean, I don't know GUID will ever be exhausted. I don't think. But yeah, there is a this problem is with integer. I have seen cases literally in my company where we are actually hitting the
it
int
will
limit.
exhaust.
Yeah, and then people suggested to go with the negative limit again, but again that will also be exhausted at some point of time, right? Negative in the sense like your integer will start from zero
But
and go to the.
one thing
But
we can do is you can always switch to big ints, right, Brijesh? And big ints can be
yeah,
used.
yeah,
That will also
but
be
it is
very
not
nice.
straightforward. It is not straightforward, right? Your
Okay.
applications are using that integer. They are defining that. So let's say you are using an ORM, or even not using ORM. You
Okay.
are yeah, mapping your column to an property in your code. So you're defining that type as int. So at every other places where this is you getting used, you're like when you are trying to, when you will like decide to use big int, it will have need to get updated. So there is a impact of, I will say the big impact.
Huh.
uh,
Huh.
Another point for from Ajit is like whether I should use a meaningful id, or like
Huh.
using a random integer auto increment is definitely, if you are using that for multiple tables, they are going to collide those values. So uh, I have seen people solving this challenge to use a single source of incrementing that id and use that id at multiple places for your other purposes. Like at one place you call it just a id or object id. Now you can use that id for a person id. You can use the same id for a different id in
Okay, so
different
you have
column.
single source to generate the ID.
Yeah, so
Okay.
basically kind of we implemented this in KubeMate also. We had a single source of id. We call id for or action id in one table. The same id is for profile id. The same id is comment id, post id. It's the same id, but we have a single source of generator. So every time a new post created, you get a new id, and it
So that
post
means
id.
if I create a post, I get, let's say, ID 1, and then
Yeah,
if I posted a comment on that, I will
yeah,
get ID 2.
two.
Correct.
Yeah.
Correct.
I will
Yes.
So
not get
so
one again for the
so
comment.
so never it will happen that your same id could be a post id and comment id. It can never
Okay.
happen.
Okay.
So
But
I have
in,
seen, yeah,
yeah, yeah, go ahead.
I mean, the same example is actually being used in my company also. So the first ID they create is they call it object ID. That same object ID now, when comes to downstream, it like creates a trading item. It creates a security ID. It creates a portfolio ID. So in multiple tables, that same ID gets propagated. But so that is actually advantage
When you
that we
say
use,
same
that
ID, I'm a
we
little
can never.
confused. When you say
Sorry.
same ID, you don't mean that the same ID number. It's like from
No.
the
No. No.
same
No.
source you are getting the
Same
ID.
yeah, source
Yeah.
Okay.
from
Yeah.
the
Yeah.
same. So it's like you keep a table, right? Or you can create a single value table also. Like in KubeMate we had a table, it only has one column id, and every time
Okay.
we hit that
Understood.
table we get new id. So and we use it at a different place. For
ID
everything
generator
we,
itself.
yeah, we hit that table. But like you can create a single table. You can store all historical generated ids also. Like 1 2 3 when gets generated, you keep in a separate table. Just that you just take that id and use it for your other downstream purposes. So the advantage it will happen is like your ids will never overlap, like every
Hmm.
time.
Yes.
Yeah, so that's how
So,
people kind of solving it. Yeah,
okay. So in this case, hitting the limit is like you're going to hit the limit of integer sooner than
yeah, so
But
that
that
use
problem
like,
is only with the integer, right? Now
yes.
we can also. So now I just want to discuss that case where I have an actual, some kind of actual attribute itself, right? Which is fairly unique. I mean, always unique, and I can use that as a primary key instead generating a new primary key, right? So in that
Yes.
case, I think if you have complete ownership, that okay, you are responsible for that ID, right? Or you are responsible for generating that ID, then it's we can still use it, right? We can still use that as a primary key. So storage wise also it will store, because even if you are using int or some other id, then it's taking extra space, right? Just for this column, and then you have this also as a unique id in that same table. So but I mean there are some kind of traps or fallbacks where this has to be called out also. So for example, let's say you have phone numbers of your customers, right? Now you will
Yes.
say phone numbers are also unique. So I will use the phone numbers itself as a primary key and not have a separate primary key, right? Then in that case, the problem with phone numbers might, the association might change, but sometimes the phone number, some X phone number is mine, it can become your also after some point in time.
Right.
So these
Right.
are the traps actually which can come. Similarly, we can talk about some other cases also where we think that okay, this is constant and this would be unique to a given case, but that it's an
But later it
interchangeable over a period
changes.
of time. Yeah. So those could be the other reasons of not using such a key for primary key.
Okay. Okay. And the composite primary key and the single primary key. Let's say that we have sufficient information that okay, we can use the no, not even that. Even let's say it doesn't matter if we are using the primary key from the domain itself. When I say domain, that means the some information from the entity itself, or you are creating your own ID, be it GUID or integer or any other thing. Sometimes what happens when you have another column, I'll take the classic example from our boat sailor and registration, right? So there what happens, you have a sailor, you have a boat, and then you do the registration, and the registration is going to be many to many registration, many to many relationship between boat and sailor. So in the registration table you will have registration sailor ID, boat ID, and the date and time, from which time to which time it is booked.
Okay.
Okay. So here the primary key could be sailor ID plus boat ID,
Hmm.
right? That will become the composite primary key.
Hmm.
At the same time, you can argue that okay, I still want to create a separate column for primary key,
Hmm.
for the registration primary key.
Hmm.
Yeah.
So in that case, how what arguments you support that I should
Hmm.
create a composite primary key here, or I should take a separate column for creating an ID for the registration table also?
Okay. So I think I have I think a good example also here to give, and what I'll favor. So basically, see, you can always combine those things and create a this single column, right? And that combination can be done by just putting, let's say, a colon in between, right? And say, and then concatenating them and putting them into single column and avoid a separate primary key. And
No, but the
so this
problem
is a
with that
good
one, no,
approach.
no, with
Hmm.
that one, the problem is like now you have those two data, right, combined together. Then the
Hmm.
filtering and all those things will be gone. Now you have to always separate them out, and then you can use them. If you merge them together, right?
Hmm.
Let's say
Hmm.
boat ID and seller ID you merged together. So
Hmm.
it won't be easy for you to do a query by seller ID or the boat ID.
Acha, you're saying how will I do those queries? Okay.
Yeah, in
Or
that
how
case
will
it
I
will be
reach that?
a problem, right?
But there's extra processing involved to basically first process that and then reach that ID and then take it, right? That is
Yeah.
one thing which I get it. Yes. Okay. So okay, there is a way to basically flatten the entire structure. So not have okay, let me not go there, but this is a very conceptual thing which is used in companies very widely, right?
Hmm.
So for example, in Flipkart, there was a concept called listing ID. Now you will think of what is listing ID. So listing ID again is nothing, but it will be a combination of the base product ID, the SKU of what is the stock keeping unit which was onboarded. There would be some ID associated with it, and then there would be a seller ID. Okay, who is a seller who is bringing? So very similar to like a seller boat, right? So there is
Hmm.
also a seller ID. Now this seller ID is associated. He is the one who basically sells this product. There are other sellers also, but he also sells this product. So now using all of these, I can create a key and I will call this as a listing ID, right? Now this
Hmm.
helps me identify uniquely uniquely the attributes of those particular products, right? Which was given by this seller and in a particular stock keeping unit, right? Instead of at a product level, right? So product
Mhm.
level, it might have a very different set of attributes. For example, the pricing, right? The pricing would be depending on a at a seller level. As a seller, I want to say this particular stock has X price. Now, another stock might have a different price, right? First, I
Right.
onboarded a set of 10 iPhones, right? Let's not 10, 100,000 iPhone I onboarded. I want to price at one level, right? At one price. Now, I onboarded a set of 100,000 second stock keeping units that I want to onboard at a different price. So now I have an ID to play around with these and identify that in the database. Similarly, there could be another seller who is also onboarded some set of 1,000 iPhones, and then he wants to play it very differently. So the base product in all the cases is iPhone. Let's say the exactly same iPhone 14 Max Pro, right? But now because these are supplied by different sellers and in different stocks, right? Because different times also the prices are different. So I have an
Yes.
opportunity to price it differently. So what I have done is I have not done nothing but came up with a concept called listing ID, which is a combination of IDs from 2 3 tables: SKU ID
Yeah.
table,
Right.
seller ID
Yeah.
table, like that.
Hmm.
So this is a concept which is generally used in the industry.
Yeah. So in this case, let's say you created the listing ID. So for whichever table this listing ID becomes the primary key, are
Hmm.
you keeping the other three columns separately so that you can make the
Yeah.
queries faster?
Yes. So now I need to first generate the listing ID, right? So I will have to keep some of the details like what is my listing ID, how does it gets created, and then when I want to know, okay, who is the seller and what is the SKU ID, right? Or for example, in case what is the boat and this, so I will have to keep a separate table where I keep that breakdown. Okay, listing ID and this belongs to this seller and this boat in your case, right? So and then with that listing ID, I can store rest of all the attributes which I want to store. So every time I don't have to go back on these two mappings, but I have a parent here, and then everything gets attributed to the parent because those all of these things are at a composite level, right? Where at the
Yeah.
mapping level, those are not at the individual levels.
Yeah. So this ID you created separately, right?
Yeah.
I mean,
It's a
instead
it's
of
a it's a
that,
new unique ID, and then
yeah,
I
it's a,
also have a language, so it gets talked about. It gets created as an entity. When people in company or developers talk about, they just to call it as a listing ID, right? It becomes a concept. It becomes a language. Similarly, in my database, in my code, always I refer to this as a listing ID instead of some kind of like seller ID combined with this, right? So
yeah,
it
yeah,
gives a very new concept altogether.
yeah. Okay. So here you're using the listing ID, and at the same time you're keeping those columns so that you can perform the better query. When I said those columns, I mean those which are the part of the your listing ID,
Hmm.
right? And so that
Yeah.
you can
Hmm.
make the better query on
We'll have
those
to keep
also
it,
by
yes.
creating the indexes.
Or
Okay.
or or let's say you want to avoid the storage space, then there are ways to basically have a way to basically process it and arrive at it, right? Let's say in your case it is combination of this, so I can put a colon in between and arrive at that.
Yeah, I
That
mean
is another
even
way.
even what you could do is that you have that listing ID, right? So
Hmm.
I don't think anyone is going to go directly to the DB and not through the application, right?
Hmm.
Let's assume that everyone goes through the
With,
application, at least through the ORM and the application. So
hmm.
in that case,
Hmm.
even if you don't store the listing ID, and if you have these three IDs,
Hmm.
you can just use the composite primary key, okay, and then
Hmm.
you have a primary key on including these three columns. And if you want to use the listing ID as a concept in your application, whenever you're fetching the data, you can translate there itself and say that okay, combination of these three becomes my listing ID.
Hmm.
So in that case, you don't store also.
Huh. That is also good, yes.
Yeah.
Only
So
thing is only thing is if because of some reason you have to change this logic, right? That okay,
yes.
I get a listing ID by combining seller ID and boat ID, then it becomes a problem Because if you have a storage space, then I don't care about how do I arrive at this logic, right? I just have to arrive it at once and then persist it. After that, I just have to write, fetch it and then write it.
Still you will have the same problem, right? Because if you're changing the logic, then whatever data you have written already, it's a bigger problem then actually. If you
No,
change
no,
the
I
logic
no no
of
no no no.
listing
Hey,
ID,
old data is there, na? So I know I have stored it that okay, this boat ID and this seller ID belongs to this listing ID. Now, whatever was the logic, right?
okay, I understood. So you're saying
I
that for
don't
the
worry
older
about it.
data, I have a different logic. For the newer
Uh,
one, I might come to a different logic.
uh,
Okay, yeah. So if that is the case, yes, I agree with that point. I have another point in this one in favor of not using a composite primary key. I
okay.
want to validate that with you two guys.
Hmm,
So what happens? That primary key, which I created, the composite primary key, somewhere I want to use it as a foreign key,
hmm,
right? Then I have to include these three columns there as the foreign key.
Yeah,
But
hmm,
yeah.
if
You
I
can't
have,
you can't use that as foreign key.
yes,
Also probably you'll have to use it as
I
a
mean, when I say foreign
text
key,
column,
I
not
didn't mean that okay, I'm going to literally create the foreign key. I can just create the same three columns there, not create the constraint of the foreign key, but use them for purpose of creating the relationship. So in that case, what happens? I need to use these three columns there in that table. So that becomes a bit problematic. I have always seen this friction. I prefer GUID. My other colleague prefers integer IDs,
hmm.
and then he prefers composite primary key. I prefer unique primary key, even though it is not from the records. Even if I need to create separately, I prefer the separate primary keys. The logic behind that I give is this one: that if I have primary key, then if I need to use that, then it becomes a problem.
Acha, Ajit, just one more reason, right? So now what I have observed in my last company, Ola, is there are mandates from the DVA side that you
Right?
must have an auto increment integer ID on your table along with some 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 other like created at and updated at. These three they
Yeah.
will mandate that you have to. The reason for that is they use this thing to create one more slave table. I'm just calling it generally a slave table, but this is used for analytical purpose, and they will copy data from this and then store it into some other place. So for
Hmm.
this purpose, and they will always hook onto some ID of the table so that they mandate it that you create it. So in all those cases, you don't have an option. Then your primary key always goes as like this auto
Yeah,
increment
I mean,
of the
yeah.
definitely.
ID.
Then this is also a
Hmm,
reason like why you need to create one ID
hmm,
Yeah, that
separately.
slave thing is a good example. Actually, you why you need to do this.
I
So
wasn't aware of it. Good, I got one more supporting argument for
hmm.
that.
Nahi, so I always prefer the way Ajit said. I always prefer.
and
I don't want to keep any extra column in my table, which is not needed. So I will try to find a unique key and then make that as a primary. That was my idea also. But then I was forced that no, you should always have this.
No,
And that
actually, what?
table is they will force the name also. They will not allow you to change. It will always be ID. I small,
Yes,
D small. That's all.
I
You
think
yes.
your
cannot name
ORMs
anything.
also enforces this, right? That you should for every entity you decide an ID.
Yeah.
I mean, kind of they say this
Okay.
is best practice that you should actually define an ID column.
And I prefer the
Hmm.
opposite, Kunal, what you said. Like, I
Nahi,
prefer
acha,
this one.
acha,
Like,
why just coming to
use
Brijesh, right?
ID
Brijesh
column,
point.
not
So that is because
something from the
they
domain.
support methods like get ID, get by ID, right? All these ID,
Right.
set ID. Now, if it is I and D, then it's all of that nomenclature completely fits. The function names, you don't have to go back and change anything. All of them exactly fits. That could be one reason for it.
Hmm.
Ha, Ajit, sorry. Hmm.
Yeah. So I was saying that okay, I prefer creating a separate column itself for the ID and not using some information from the entity itself.
Hmm.
I don't trust the uniqueness of the data.
Hmm.
For example, the phone number. So
Hmm.
I prefer to have create separate ID itself.
Hmm.
And rest wherever needed, I'll create unique or those things if needed. Indexes I can create. Okay, I think those were the 2 points when it came to indexes. So these were 2 topics related, and it was running in my mind. So I thought to.
One, have you guys seen anywhere sharding be used for RDBMS?
Okay, so honestly, personally, no. But I have heard about it, read about it, that people are. I think there are tools also. Somebody mentioned that there is a new company which is saying that okay, you don't have to move to NoSQL. We will support sharding in your RDBMS only. But okay, but let's say if you have to do sharding in MySQL, the thing is it will start becoming more like a NoSQL. It's not like impossible. You have to own the sharding logic in your
Yeah,
application, right?
because
So it's just you will say that okay, this range of data lies on this server, this range of data lies on this server, and I will use some kind of let's say make a lookup to some kind of a hash store or something to know that okay where my data is located, and then I'll go to the data. But having
yeah,
said that, now you'll not be able to use the full-fledged advantage of an RDBMS, for example, joins, right? You'll
yeah,
not be able to perform joins because now your data are in two different tables. There is no, it's not possible, I think, to now join them.
I think, yeah, I
yeah,
mean,
yeah.
I have seen it in one place in my application, but that is for the time series data. So we are using PostgreSDB, and
Hmm.
you have time scale plugin also. So if you use the time scale, then you can store the time series data, and you will have time series data related functions also available with that. So there it uses sharding to keep the
Mhm.
data of one day in one location, one page, and for other day in the other page. So that's the place where I've used. But in this case, like Kunal, you mentioned, I don't need to join on that because I have the time
Huh.
series data. So I just get data by the time. So I don't need to join there. So yes, that limitation doesn't
Yeah,
come
yeah.
here
I mean,
in my case.
RDBMSs were designed not keeping sharding in their mind because there were no need at that time. I think the data were pretty able to kind of uh,
Contain
they were
within it and not.
yeah, they were able to store in a single machine. They were not needed
Yeah.
to.
So let's go to the core of this, right? What is so inherent in RDBMS or
Mhm.
any relational DB that it it basically cannot be scaled, right, up to a certain, or basically let me put it, it cannot be horizontally scaled, right? It can only be scaled vertically, and vertical scaling, of course, has a limit. You can go maybe up to, I don't know, in recent years 256 GB of RAM, right? or or more than that, 1 TB of RAM if some the servers might be supporting, right?
Yeah,
Not
seen
beyond
that.
that. So what is there something inherent in RDBMS which prevents it to be done like that?
Like what?
Well, I think Kunal's point is that they are not horizontally scalable. Something which is stopping
Hmm.
RDBMS is not.
Not
Uh,
becoming horizontally scalable.
yeah.
I,
No, I think it
no, it
all
doesn't
drills down
stop.
to
Actually, it's all the philosophy. What kind of data you want to put there, right?
no. I think the point is that uh, it's basically depends on how you are storing and retrieving and what data you need to uh, fetch in your application at single point of time. So like RDBMS says that data basically uh, are relational. I mean, if your data is not relational, let's say you have one table for one feature, you have everything related to one logic in one table, you can like do that same thing. Like you can put your data in different table on different machines horizontally, keep it, and like make your custom sharded logic, your consistent hashing logic, and then just go and fetch your data, right? If you if your single data is at one place, whatever data you want for uh,
Hmm.
I think SQL provides you like more features,
Hmm.
and then definitely if you have more things, more features available, then you will have constraints on that. For example, if I say it provides ACID, then
Hmm.
when you get the ACID, then you have a precondition for that. So those are the limitations mainly are like the limitations on the RDBMS. I mean, if you're saying that, okay, I want to use a relational DB and maintain the foreign key constraint also,
Hmm.
right? Then definitely you're not going to get that performance which you get without having the foreign key. So it's like you are getting extra feature of having the foreign key, which you don't need to maintain in your application. Your DB itself will validate that
Hmm.
this relation is existing, right? There is no registration without a boat.
Hmm.
So
Hmm.
so in that case, you get a limitation of the speed there. So I think these kind of things are there which limits the RDBMS.
Hmm.
So it's like if you want to get something, you need to forego something. So that's what happens in this case.
Yeah, yeah. I think fairly. So, of course, one, as you mentioned, acid, and then generally the relation that it tries to maintain, not just in one table, but also among different tables, right? So, because
Yes.
of these constraints, then RDBMS tends to become non-horizontally scalable, right?
Hmm. Uh,
Um,
for example, you mentioned the joining thing, right? So
mm,
if you have data in different places, then obviously you will not be able to join them.
mm,
And then if you say that, okay, I don't support join, right?
mm.
Then there is no restriction from that point of view, and then you can keep your data in different
You
locations.
can apply custom shardings, yeah.
Yeah.
In that case, yeah. So I think this is the point. Even NoSQL says that, okay, well, let's say if we talk about that flavor of NoSQL, which is just key value pair, then
Hmm.
you say, okay, I have only key string and key value, very simplistically. So I store where it. How does it matter, right? And I am
Yes.
able to shard it based on some logic on the key,
Yeah. I mean,
right?
if there also, if I
So.
start using join kind of things,
Hmm.
then I don't think it will be possible to shard.
First, right. And first of all, it's because even let's say there are four flavors to NoSQL database. One is key value. Now second is a columnar database. So columnar are trying to maintain some kind of relationship, at least in a row. They say, okay, there is a column family and all columns of same type will be in one column family. And but there is a concept of row. For example, big table has row ID, right? Cassandra, I think, also uses the same thing, Cassandra HBase. So they're also, but they never say there is relationship among different rows. It's also always one row, so
yeah,
that because they can support auto scaling tomorrow, if they have to pull this row out of one shard and put into some other shard, they can easily do it, right?
Hmm.
So they are also trying to play on non relation among the rows only, right? Which MySQL can't do, because MySQL now, or let's say a relational DB can't do, because they have to maintain that relationship somehow, right?
Yes. I mean, if you have read this book, Clean Architecture,
Okay.
so there is one statement I relate it many places that many powers are taken away from us in
Hmm.
terms of ability to write the code or saying that okay, it is a good practice, so that we don't mess up things.
Hmm.
For example, there are three topics there. If I refer, I'll remember it correctly. I'm not able to recall it now, but the whole point was that, for example, if you have assembly language, you're
Hmm.
writing code in assembly language, then you have full power to access the memories and do all kind of stuff, right?
Hmm.
But at the same time, you might corrupt the system also.
Yeah. 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 Hmm.
yeah. With great power comes great responsibility.
Yes. I mean, that statement I have, after reading, I was like, that's a point.
Hmm. So the other point is I think consistency point is how is it the consistency in RDBMS versus consistency in non-relational DBs, right?
Hmm.
So I think Brijesh, you can talk about this.
No, I mean, I think that actually clarifies that in RDBMS consistency means that your relationship among data, I mean, you define various constraints that these these could be the only valid values, uh, and consistency is just about ensuring those constraints or adhering to those constraints. Uh, whereas in like distributed systems, consistency is another thing where you have data at multiple places. You keep them multiple places just to become, yeah, I mean, for various reasons, distribute load or something. So their consistency says that if multiple readers are reading from multiple places, they are reading the same value. That's defines the
That is
consistency.
in yeah, non-relational, yeah.
Yeah,
So does the non-relational databases support transaction?
I mean, transactions, I mean, it is up to you how you define transactions.
Yeah.
So
For
uh,
example, in relational database, what we say is, okay, my transaction starts now, and whatever operation I'm doing, these will
so
be in one transaction till I commit the transaction.
in RDBMS also consistency is kind of tunable thing. So you have probably heard about the isolation labels. Various. Let's discuss about them. So
Yeah.
the isolation labels defines that particular thing. That how, I mean, like in a scenario where multiple transactions are reading, writing, what like level of consistency you want your readers to see. So it's like less consistent and versus high consistency. So less consistent ISO level we say, what we say, what's the name of first isolation level? Tell me.
I don't know.
There are four, right? Last one is serializable, that actually ensures the highest consistency, and then is okay, read uncommitted. So first is read uncommitted. So when you decide to go with read uncommitted for your, so it is actually defined per transaction. So for every transaction, for every read, you can define your consistency levels. So you define a read uncommitted. That basically says that just go and read the data, even though there is a transaction which is currently not committed, and it is actually reading that data or modifying that data. So let's say if you are querying with read uncommitted, it will go and read the data. Whereas it will happen that when the other transaction, which was actually not committed at the point when this transaction read that data, what at the end that transaction modifies that value when it committed. Whereas your transaction with read uncommitted has already read that data. Now you are in inconsistent state, right? Your data is
Yes.
something else, but you read something else. So this is
Yes.
actually read uncommitted consistency level.
First.
Then you go with read committed, that only read committed data, and then there is repeatable read, and then is serializable. I'm not sure we are going to discuss all of them, but yeah, this is actually the debate about you can tune your consistency levels with RDBMSs too. You can read inconsistent data. So
I mean, what I meant by that question, like the question that does the NoSQL DB supports the transaction? I'll again take our classic example, sailor boat and registration of that. So let's say I did the registration of a boat for a particular sailor, and then I recorded the payment details also, right? So what I want is, if I did the registration, I should record the payment detail also, either both or none. So this transaction support we get in SQL.
right.
Do we get this kind of transaction supports in any of the NoSQL DBs? I have not used NoSQL DB.
I also haven't, but I think they do support. Maybe Kunal can explain
So
something.
so So again, the thing is that in cross table, let's say if your scenario is basically I have table A, table B, table C, three tables I have. Now, what
So
you are
table in the
saying is
sense you're
either
talking RDBMS.
so loosely, I
Let's
think
say entity, you can
most
say
of
now.
the NoSQL also have similar kind of terminology. Some will call
Okay.
table, some will call collection,
Document.
some will call document or something like these are the things. So I will loosely using that table terminology. Now
Okay.
three tables are there. What Ajit means by transaction is that either my changes are made in all the three tables or they are made in
Mm,
none of the three tables,
none
right?
of the
So this is
yeah.
what you mean
Yeah.
by transaction. Now this I think generally speaking, this will not be supported by NoSQL.
NoSQL.
Yeah, you can at a given table level, it supports transaction. It can say that okay, this will be either that data will be entered into the table or not entered into the table.
Or
That
not
kind of
entering.
guarantee is there. But across the three tables, you have to do this in your application logic itself. It will not be
Mm,
controlled in the DBMS. Sorry, in the
in the
database server
storage.
level.
Yeah.
At a storage level, it will not be controlled because for them it's very different thing, right? Just think of, I mean, if I take example of very vast MySQL, what can happen is table 1 might be stored in some Australia, right? Some data start in Australia, table B might be stored in India, right? And table C might be in some other continent. Now for me to give such a kind of guarantee would be very difficult if it is NoSQL table. So generally I'll say no, but I think we'll have to see it specifically if some kind of support has come at any
Yeah.
given level. Yeah.
Okay.
Yeah, I
And
think it's
then
always that debate of consistency versus availability. Like if
yeah.
you are going to ensure that all your copies gets written, then again you are sacrificing your availability. So
Yeah. So I
Right.
will just like to talk about one thing here, which
Mm-hmm.
is Google Spanner, right? I have tried to read the paper from Google on Google Spanner. Now, the unique thing about Google Spanner is that the developers uh, actually they actually claim that we are able to achieve acid, sorry, not acid, this cap theorem, right? So cap theorem, what it says is that you can either have a CP system or an AP system, right? Now this Google Spanner says that we are a CP system, but we also support industry standard 5.9 of availability, which is 99.99959 nines. This availability also we support. So which is typically making this as overriding the cap theorem, right? So now how they do it is they have basically come up with a concept called true time, and that true time they arrived based on the GPS data and then atomic clocks, and then they keep the version of each of the data. So each time, let's say one data will be updated, along with that same data they will update uh, one would be the ID, how to access that data. Let's say the primary key, which will be a row ID or something. And then one would be the version of that data. So the same data can be written 100 times and the latest version will have the latest timestamp. So timestamping is done for each of the version. Now what they do is they try to basically using this concept of true time, they try to have a very minimal gap, right? They will try to synchronize. Let's say there are two servers. One server is at a place, another server is at a B place, right? Now they will try to synchronize the time clock between these two. And for external system, when I want to know, okay, give me the value of this data set, then I can control where to send this data, where to send this call, and then I will be able to serve the latest version of the data only. So I will always be consistent, right? So for example, if you heard about this concept called in sync replica, right? Like for example, Kafka supports this. So what happens is, let's say, just to talk a little bit about on this so that we can relate the same concept there. What happens is, let's say their replication ratio is 3, right? 1:3. I mean, one primary and then two
two
replica sets, right?
slaves.
Yeah, two slaves. So what happens now? Kafka will support various kind of modes, acknowledgement modes, and it's basically a trade-off between whether you want to be very sure, you want to support strong consistency, eventual consistency,
Yeah.
or no, right? So now what happens is, now you write the data to Kafka, right? The leader will accept it, but now there are two replicas. Each of the two replicas are trying to copy the data from the leader in an async fashion. Okay, it's not sync copy, it's an async copy. So in real world, these replica are lagging maybe by few microseconds, milliseconds, or maybe by few hours, depending on a few whatever, right? The timeline can lag anywhere. Now let's say if you tune Kafka for, let's say, strong consistency, right? So Kafka will say that, okay, in this case I have to write I have to let all the other two replica also catch up, and once they also copy the data and then send me the acknowledgement, then only I'll send it to the client that, okay, the data has been written, right? Only then you will send to the client that the data has been written, because I want to maintain the strong consistency. Now you will say I want to maintain an eventual consistency, so it will say, okay, let one of the replica also catch up with me, and and one replica has catch up, then I can send to client that, okay, it's consistent, and the other replica which is lagging behind, that can eventually catch up, right? So these are the concepts, and to be there is a formula also given. I mean, I've just talked about loosely a case of 3 replicas. So they say that when your read when the number of your replication ratio plus number of in sync replica is greater than okay, I forgot the formula, let me not say that, but there is a very clear cut formula which they say that, okay, if these many servers are in async replica, which will be certain ratio of the overall number of replications that you have, then that means that it will always give a strong consistency,
So
and in otherwise
is
it will give a weak consistency.
is it mentioned in Alexu book first part 1?
So it's
Right.
mentioned in, I think, second part, not first, second. So second
Second
part has a topic called designing distributed queue.
Hmm.
So there they were talked about this. All these are like Kafka concepts, but loosely, yes, any distributed queue should support this. And this is they are talking about this in very detail here. There.
Yeah, and that part where you wait for some number of replicas to confirm the right.
So
That
it's for you,
quorum
right?
call.
For the developer. Now you want to say that, okay, I want my cluster to be strongly consistent. So you will say that I will arrange this formula so that is greater than that minimum. The single
given.
replica is greater than this.
Yeah, okay, understood.
I think simple read plus write is greater than number, right? So it's like if you're reading
I think
from 3,
it's
writing on 2, reading from 3, and your number is 5, then you are consistent, right? You are reading from 3 always. Sorry, no. कुछ ऐसा ही है.
Something like that.
yeah,
Also, I just
something like
missed
that.
the
I
code.
remember now when Bridges said read and write. Yeah, I remember that when I read
Correct.
it in the Alexu book. Yes.
Okay. Any other concluding remark, or we can pause
This
it?
was a really good session.
So thank you so much for watching. I hope you like the content, enjoy it, and learn something from it. And please do write to us in comments if you have any questions surrounding this topic or any other topic like system design or something which relates to software engineering. We will try to come up with a video and answer those questions in the comments. Thank you so much.